Imagine rewinding the entire universe. Every galaxy begins moving backward. Clusters of galaxies merge. Stars disappear. Atoms break apart. Space itself shrinks. The vast cosmos contracts into a state so hot and dense that our ordinary understanding of reality begins to fail. This is where the story of the Big Bang begins. But not in the way most people imagine. For decades, the words Big Bang have created a misleading picture. Many people imagine a gigantic explosion blasting matter outward into empty space. But according to modern cosmology, that is not what happened. The Big Bang was not an explosion in space. It was the rapid expansion of space itself. There was no center. No edge. No surrounding emptiness waiting to be filled. Every region of the universe was part of the event. Every point in space participated in the expansion. In a sense, the Big Bang happened everywhere. And that idea is far stranger than any explosion. To understand this, imagine standing on a vast rubber sheet. If the sheet stretches, every point moves away from every other point. No single location is the center of the expansion. The expansion happens throughout the entire sheet. The universe behaves in a similar way. As space expands, galaxies become separated not because they are racing through empty space, but because the fabric of space itself is growing. This simple idea would eventually transform our understanding of reality. But how did scientists discover it? The answer arrived through light. In the early 20th century, astronomers began analyzing light from distant galaxies. When an object moves away, its light stretches toward the red end of the spectrum. This effect is called redshift. The farther away a galaxy was, the more its light appeared stretched. The conclusion was unavoidable. The universe was expanding. And if it was expanding now, then it must have been smaller in the past. This realization changed everything. For the first time, scientists had evidence that the universe was not eternal in its current form. It had a history, a beginning, a story. Yet evidence for expansion alone was not enough. Scientists needed another clue. A clue that would survive from the earliest moments of cosmic history. A signal from the infant universe itself. Remarkably, they found one. And it was hiding in plain sight. In 1964, two radio astronomers named Arno Penzias and Robert Wilson were testing a large antenna. No matter where they pointed it, they detected a faint background signal. At first, they assumed something was wrong. Maybe the equipment was malfunctioning. Maybe nearby radio sources were interfering. They checked everything. They even cleaned bird droppings from the antenna. Yet the signal remained. Persistent. Uniform. Coming from every direction in the sky. What they had discovered was one of the most important pieces of evidence in the history of science. The cosmic microwave background. The oldest light humans have ever observed. Today this faint glow surrounds us. It arrives from every direction in space. Invisible to our eyes but detectable by sensitive instruments. It is a relic from a time nearly 13.8 billion years ago. A fossil of the young universe. A snapshot of cosmic infancy. Imagine finding a photograph of yourself as a newborn. Now imagine finding a photograph of the entire universe when it was less than 400,000 years old. That is essentially what scientists discovered. And the image revealed something extraordinary. The early universe was incredibly hot, incredibly dense, and remarkably uniform. Exactly what scientists would expect if the universe had emerged from a much hotter and denser state. The Big Bang model suddenly became far more than an idea. It became a theory supported by observation. But despite its success, there is something important to understand. The Big Bang theory does not explain everything. Many people assume it describes the absolute beginning of existence. In reality, it describes how the universe evolved from an extremely hot and dense early state. When we trace the universe backward, our equations work incredibly well for much of cosmic history. But eventually, we reach a point where our current understanding breaks down. A boundary known as the Planck Epoch. A time less than 1/trillionth of a trillionth of a trillionth of a second after the beginning. About 10 superscript 3 seconds. At this scale, gravity and quantum physics collide. And our existing theories cannot fully describe what happened. This is one of the greatest challenges in modern science. We possess two extraordinarily successful frameworks. Einstein's theory of gravity explains the large-scale universe. Quantum mechanics explains the microscopic world. Yet when we try to combine them under the extreme conditions of the earliest universe, the mathematics becomes incomplete. Somewhere beyond that boundary lies a deeper understanding of reality. One scientists are still searching for. What happened before this moment? Did time itself begin there? Was there an earlier state? Could our universe be part of something larger? The honest answer is that we do not yet know. Many fascinating ideas exist. Some involve quantum fluctuations. Others suggest cycles of expansion and contraction. Some propose entirely new structures of space and time. But at present, none have been confirmed. The frontier remains open. And that uncertainty is not a weakness of science. It is one of its greatest strengths. Science does not pretend to know what it cannot yet prove. Instead, it continues asking questions, building better instruments, testing new ideas, searching for evidence. Because every major discovery begins with a mystery. What we do know is astonishing enough. Nearly 13.8 billion years ago, the observable universe existed in a state of unimaginable temperature and density. Energy filled every region of space. The cosmos was smaller than anything we can easily comprehend. There were no planets, no stars, no atoms, no galaxies. Not even light could travel freely. The universe was a cosmic furnace unlike anything that would ever exist again. And within this extraordinary environment, the foundations of reality were being established. The laws of physics, the forces of nature, the ingredients that would eventually form stars, worlds, oceans, and living beings. Everything that exists today traces its history back to this primordial era, including us. Every atom in your body, every mountain on Earth, every distant galaxy visible through a telescope.